All right, good morning, afternoon, evening, depending on which time zone you're dialing in from. To everybody, thanks for joining us today on this webinar about the EU Methane Regulation. So we are joined by experts from different companies today. I'll introduce everybody. But first, a few opening remarks. So as the title of the webinar suggests, we'll focus on some key regulation elements. So the regulation itself is, I don't remember exactly, many pages of document and a lot of detail, but yeah, we'll focus on a few elements there. We can look into the crystal ball a little bit because of course, this is kind of the first step that the EU has taken towards abating methane emissions. And there has been a lot of talk about what happens next. So over the next few years, what will happen, nobody really knows exactly. But yeah, there are some discussions going on. And based on our joint experience, we can give a few comments on that. What we don't want to do, what we did not want to do today is really just describe the regulation to everybody, because yeah, in the meantime, it's for people that are in the industry, it's pretty kind of understood, well understood. So this is why we actually have representation from 3 different companies working with very different technologies, which are helping operators become compliant to the regulation, and therefore we'll focus a bit more on real use cases and experiences that we have as a team made in the field while helping our customers achieve compliance to the regulation. Something a bit administrative, the webinar will be recorded. It is being recorded. It will be available on official social media channels. So yeah, thank you for agreeing to that. And during the presentation, feel free to write your questions and comments in the chat, and we'll try to handle at least some of the questions in the end. And yeah, before really starting, let me also thank everybody, all the panelists, first of all, who have joined as well today, who I will be introducing now. But yeah, thank you for taking the time and bringing your expertise to the webinar today. All right, so yeah, let me introduce everybody and myself maybe first. So I'm Sanket Bhatia, I'm CEO at SensorX Solutions. We are a Swiss company, a pretty young company, young startup, I would say, founded a couple of years ago. We have a team of experts who come from gas measurement technology. That's how we started out. So gas measurement technology, hardware and software. In the meantime, because a lot of our customers in the methane space, in the natural gas industry, also ask for inspection services. This is also something that we are following into. I will speak a little bit about that later, together with one of our partner companies, a very strong partner, Heatech Solutions. So from Heatech, we have planned Amin, who's the president. I'm not sure if he's joining or not, but then there's Ashwin. He has certainly joined. He's the manager and project engineer at Heatech. So he will be speaking a little bit about the technology that Heatech has implemented, the areas that they're active in since I think almost 60 years in Canada. So it's a Canadian company, one of the leading companies in Canada in this field. Then we have experts from Opgal, a worldwide name in optical gas imaging cameras, based out of Israel. So there's Ilan, Senior Director, Business Development, and Ram, the Chief Innovation Scientist, joining as panelists today. All right, so that's us. Yeah, what will be the structure like? So yeah, the topic, as you know, is, are you ready for the EU Methane Regulation? And there was a little bit of joke hidden there. So we put in some of the text regulations, which is fine, because yeah, it is first of all a complicated piece of regulation, a lot of detail, and there's a lot of more detail coming in the next few years, so to say. So if you kind of look at it that way, it's a lot of different requirements. So in that sense, it can also be construed as a group of regulations. But yes, that's the topic for today. So yeah, we will speak about the key requirements of the EU Methane Regulation, EUMR for short. We'll speak a little bit about the timeline. That's already a couple of those milestones have passed, as some of you may know, and quite a few milestones are coming up in the next, in the rest of this year, in the next years, and so on. Technology landscape. So of course, there's been a lot of innovation the last few years because methane is such an important topic. So there has been a lot of innovation on gas detection technology to help companies quickly look for methane leaks and repair them. And because we have 3 technology companies joining us today in this webinar, we will, in a natural way, also be speaking about some of the measurement technologies out there. But of course, there are a lot of other technologies as well, other than the ones that are represented today. We'll speak a little bit about the expected pathway. So what else is expected in the coming years as the regulation evolves, as it becomes more stringent, and so on. Then I'll pass it on to Ashwin, who will speak about quantification, high flow sampling, and leak inspection services, all areas where ETEC is an expert at. Then it would be Ram from OPCAL, who will speak about visualization and quantification with optical gas imaging cameras. And then I will speak a little bit about the sniffing solutions that SensorX Solutions has brought, where we help companies do surveys on drones, on vehicles, walking surveys, and stationary surveys. And then we'll close up with a short question and answer session. All right. So that's kind of the structure. Yeah. So let's start with the real topic for today. So what is the EU Methane Regulation? So just a little bit of background. The original seed of the regulation can be traced back to the Global Methane Pledge, the GMP. This happened a bit before 2020, where a lot of companies, especially kind of initiated by the UN EP group, came together and made some pledges about reducing the methane emissions, because methane is a very strong greenhouse gas, as all of us know, and a big contributor to climate change. And the original goal, though it's not yet reflected very well in the regulation, but the original goal was to reduce methane emissions by at least 30% by 2030 compared to the 2020 inventories. So that was kind of the origin of how the EU Methane Regulation stone started turning or rolling in that sense. And then there were a lot of discussions, like with most of such regulations, especially at the EU level. Finally, some kind of agreement was reached by late 2023. The EU Methane Regulation is certainly the first EU-wide regulation tackling methane emissions. There have been some regulations previously which still exist and on the non-national levels, in Italy, for example, in Germany, and so on. But this was really the first EU-wide regulation tackling this topic. The requirements in the regulation are for the oil, gas, and coal sector. So all other sectors, for now, they are not part of it. There has been some discussion about including biogas and also other sectors which are a big emitter of methane, basically. But right now, it's these sectors which are under the purview of this regulation. If we kind of look at the regulation very high level, there are kind of two components to it. There is the MRV rule, so monitoring, reporting, and verification, that the data is being collected and emissions are being monitored and reported. And then there's the second part, which is the LDAR, so leak detection and repair part of it, which is then repairing those leaks which cause the emission. So there are these two big parts. And then there's one more part which basically bans routine venting and flaring of natural gas or any gas that contains methane in a high quantity. So there's that part as well. All right, so yeah, that was the background, how it started. To take this topic away, of course, if you have a regulation like this at such a large scale, there's, of course, you can never make everybody happy in that sense. So yeah, there is of course some justified and maybe some unjustified criticism of the regulation as well. Just a few points here. There is no implication for imported energy sources. So Europe itself doesn't have much upstream sources. So there's not a lot of gas being mined here in that sense. So Europe relies a lot on imported gas, and then there is no implication for imported gas yet. So this is kind of foreseen in the regulation, and this is already now a big topic with Trump and the US and so on, where there's a big pushback. But yeah, this is not something which is covered in the regulation today. There is no timeline to implement a maximum methane leakage rate, so there is no kind of ceiling which has been defined so far, which kind of brings me back to the point which I mentioned earlier. There's no real connection to how much reduction we are hoping to achieve through this complicated regulation. So that's the third point as well, no overreaching methane emission reduction target. And then one big sector which is not covered is the petrochemical sector. So really kind of the oil and fossil fuel sector, which is other than the natural gas part of it. This is all not covered, which is also a big emitter of methane. Those are just a few critical points that are raised often. Right. So kind of let's discuss a little bit what are the exact requirements. What is the regulation asking for? So yeah, I said before there are these two parts. There's the MRV part, the reporting part. What we are still waiting on are some of the implementation acts. So the regulation has been adopted and passed, but then on national levels by each of the competent authorities, there will be kind of implementation acts which will be implemented in the coming time, in that sense, which will define, for example, the reporting methodology. And there is no clear scope and timeline for the implementation acts yet. Yeah, so there's a lot of rumor, and there are some things which are already planned that most people know, but there's no real scope and timeline yet. What has been said in the regulation is, in the meantime, till the methodology is not finalized, there's a lot of relation with the OGMP 2.0. Yeah, so this is the other big international framework, which goes back to that GMP I spoke about before. So in the meantime, the operators have to use the technical guidance documents of the OGMP while reporting methane emissions. What is said in the regulation is, in case of discrepancies between the regulation and OGMP, operators need to notify the competent authority and undertake a reconciliation process. So this is already defined in the EU Methane Regulation. Right, so that's the MRV part, and then we come to the LDAR part. The LDAR part is a risk-based approach. So basically, if you find big leaks, you need to repair them. You need to repair bigger leaks before, basically, putting it in a simple way. In the regulation, there are two types of LDAR surveys which are defined. There is the type 1 survey, which is a more kind of frequent survey that needs to be done, usually for larger leaks. So kind of find the larger leaks more quickly, in that sense, through more regular testing. And there, the limits that have been set are a bit higher. So they are kind of meant for larger leaks. The limits that have been set are either on the concentration level or on a leak rate level. So 7,000 ppm on a concentration level, or a 17 gram per hour leak rate. So these are kind of seen as equivalent within the EU methane regulation. It's very confusing in discussions. I mean, this I can tell you from all the discussions that we have with our clients and partners and so on, whether it's the concentration that counts or the leak rate, the quantified leak rate, and so on. So that's a big discussion. We won't go into that today, because sometimes there's a bit of opinion in there as well. Right, and then there's the type 2 LDAR survey, which is a lower frequency survey. So the frequencies are defined in the regulation in more detail, according to what kind of facilities and what kind of construction material of the pipelines and things like this. So that's a bit more detail behind that. But the type 2 LDAR surveys, these are then done at a lower frequency. For example, for some of those assets, once a year is enough. And these are meant to be more comprehensive investigations so that also the smaller leaks can be found. And that there the limits are kind of also smaller than what is in the type 1 survey. So it's 500 ppm or 1 gram per hour, or 1000 ppm or 5 grams per hour for underground components. So yeah, those are the two big components of the EU methane regulation. I'll speak a little bit about the timeline. So yeah, what has already passed, what was defined was by 5th of February this year, the competent authorities in each of the countries or even the regions within the countries should be defined. We know from experience that this deadline wasn't met everywhere. We know a lot of countries and regions where the competent authority was still not defined or was kind of already indicated, but not really formally communicated and so on. But yeah, in the meantime, it's becoming more and more clear. By 5th of May this year, the LDAR program needs to be or had to be submitted by all the operators. So yeah, this is already passed. So yeah, everybody, so all of our clients, for example, have already submitted this. What is coming up next is 5th of August. So yeah, that's where the real fun starts in that sense. That's when the regulation says, yeah, the type 2 LDAR program for assets should be complete, it should be done. And this can be in a first stage, it can be done using generic factors, but generic factors also need to be kind of derived from real measurement values. So there is some kind of definition there, what can be done and what cannot be done. And then a verified annual report, which will contain details of source level methane emissions needs to be submitted. The level of detail, it is already mentioned, the level of detail will increase every year over the next few years within the regulation. So these are kind of the main deadlines which are right now happening or kind of pretty close. What's happening in the next years is by February of 26, source level quantification with source level factors based on measurements for operated assets needs to be done and completed and reported. In 27, we go for source level quantification, site level emissions and reconciliation. So then between source level and site level, there already needs to be reconciliation, that the total emission from a specific site also kind of adds up or kind of adds all the emissions from all the sources within that site. So that needs to be done by 27. That adds a bit of complexity compared to what is valid today. And then later by 28, also non-operated assets and so on so there will be a lot of reporting required for non-operated assets as well. So this is kind of the main timeline, the main dates. Maybe a short word on what it means as far as penalties are concerned. By the way, I mean, depending on which faction you listen to, the penalties have also been discussed, whether it's high enough or not, since there has been quite a bit of discussion, especially when we compare the penalties that were defined in the US already a couple of years ago through the Inflation Reduction Act. Some people said, yeah, in the EU it's not that stringent, but it is pretty stringent actually, in my opinion. So there are defined penalties of up to 20% of annual turnover, and that's a huge fine that operators can incur if they don't comply with the regulation. All right, so yeah, that's a little bit kind of a quick run through of requirements. And then, yeah, maybe a few words on, yeah, what's being discussed out there. There are a lot of working committees and, things which are planned. The EU is kind of also communicating a few things, but yeah, it's still, of course, a lot of conjecture and rumors about what's planned. So yeah, what we certainly know is the discussion around the import rules. I mentioned that before. That's an important part of the regulation, which is foreseen in the regulation in the coming years. But yeah, there the tug of war already starts. For example, so I mentioned the pushback from the US already happening now. So we will see where it goes. So I don't want to guess here what will happen there. What I mentioned before, the implementation acts, these will come up pretty soon on national levels, and then also on certain topics like defining measurement technologies. So which kind of measurement technologies can be used for which kind of surveys, for example. These are hot topics. These are being discussed quite a bit. The limits of detection of the instruments that can be used to do those methane measurements, for example. So yeah, these are all topics which will then become part of the regulation moving forward, is what is expected. And then there's a big there are a lot of national regulations as well, and yeah, the goal is always to kind of simplify things and streamline things so that the national regulations also come in line with the EU methane regulation. So yeah, there's kind of a push there as well on national levels. For example, the DVGW in Germany, which is traditionally only focused on safety issues, is now also looking to kind of how to unify itself with the EU methane regulation in that sense, so that it also reduces costs for the operator, so that they don't do different surveys to fulfill different regulations, but can optimize costs. The NEN in the Netherlands and so on. So those are also that topic also creates a lot of discussion actually. All right, so yeah, I'm done through kind of a quick run through of what the regulation means, and I'll pass on now to Ashwin from HETEC to speak a little bit about what HETEC does and experiences from the field, and kind of join that to the regulation.
Thanks, Sanket. Hope you can see my slides.
Yes.
All right, perfect. Well, thanks for having me on, and it's great to be able to present this afternoon. So HETEC Solutions, for those of you not aware, as Sanket mentioned, more than 6 decades, actually almost 7 decades, we've been around next year, mainly in the upstream, midstream, and also downstream oil and gas industry. Methane emissions, gas leak surveying has been our expertise, and we've been doing a lot of work with respect to fugitive emissions surveys. We also are familiar with the OPGAL icy gas camera, which we've also used during our surveys as well. Portable gas detectors, calibration of fixed gas detectors. So we kind of do it all. We're Canadian based with our products worldwide. And today I'll be talking about the fugitive emissions quantification with the HETEC flow sampler, which was built to replace the legacy backrack high flow sampler. So the design really began with intrinsic safety and hazardous locations with the most up-to-date IECEx regulations for NRTL and also ATEX. So we achieved our certification a little more than 2 years ago with the NRTL in North America, and then with ATEX as well. It is still the only commercially available sampler that is ATEX certified for Class 1, Division 1, Zone 0 for intrinsic safety in hazardous locations. So that is quite a stringent standard to adhere to, and we have that certification, which is quite important to make sure that safety is on top of mind amongst different types of environments. Mainly it is to encapsulate fugitive emission sources. So it is focusing on fugitive emissions, leaks, and just encapsulating that. Sanket mentioned about the OGMP. So OGMP 2.0 level 4, that details about source-based sampling. So we basically go to the source and sample. So we try and get as accurate of the emission as possible. And the flow sampler will be one amongst many quantification technologies that are out there. We recognize that, there are satellite-based solutions, there's fixed-wing aircraft, there's drone-based solutions, there's vehicle-based solutions. There are point samplers. So our spectrum is towards the point source level, where we are able to pinpoint to which component and getting its emissions from that. So there's positives and advantages to each sort of method, and ours is very much with respect to the point source level and also the accuracy that comes with it. In terms of the EU Methane Regulation, so the Type 1 LDAR surveys, which is less than 17 grams an hour. So our full sampler, the minimum quantification limit is 4.95 grams per hour of methane. So mainly above, we target the above grade components. And this instrument's used in conjunction with pinpointing an emission. So using a portable sniffer, for example, or an OpGal IC gas camera, you know which particular component the emissions coming out of, and then you would go and quantify with this. So it has to work in tandem with other instrumentation for detection, and then it will do the quantification. Some of the key markets, upstream, midstream, and downstream energy industries, wherever there is the presence of methane or natural gas infrastructure, natural gas utilities, regulator stations, compressor stations. These are all the different locations in which the flow sampler has been used. And also in terms of geographical locations, these are some of the countries that we have the flow sampler in, and of course they travel from country to country. So a lot in Europe, North America, South America, and also the Middle East as well. So ensuring that the equipment is safe to use in all these locations and a hot work permit is not required, for example. So that's some of the key elements with respect to the markets and locations. Going on to say the applications. So we have had the flow sampler used in offshore facilities. So offshore oil rigs, it's been used in those areas where it's really sensitive and you need to have a zone 0 instrument. So it's been used in those environments to capture emissions. Petrochemical facilities, where there's a lot of different products that are being produced in the facility, and the flow sampler is used to mainly gather the emissions from different components. Another interesting applications are on LNG facilities, including vessels or LNG ships. I actually went with the flow sampler on one such opportunity in the United States. And they were exporting LNG to Europe. And on those vessels, we did some testing for both the components that were exposed to atmosphere as well as that which was close to the engine room. It proved to be quite effective and efficient. And also being Zone 0 certified with ATEX certification, it was the only flow sampling device that was actually allowed on the ship. So that was something that was really unique. And also natural gas utilities. So once the gas is sourced, then it gets distributed to transmission mains and also distribution mains. And there's various compressor stations and regulator stations that go along the way. So it's used on those environments for all different types of components. Also on the upstream side, abandoned wells, and operating oil and gas facilities. So these are the different applications in which it's been used, and we have found that it's portable, so it can, for example, at the offshore side, one can climb ladders, or at a compressor station, climb the ladder to the vents and see how much emissions is venting. So that's also a key aspect to that. Going into some of the future development of where we want to head towards is achieving the lower threshold limits for performance and design, less than a gram an hour, making sure that we have increased accuracy even at those lower limits, and being able to capture a wider range of leak emissions and also smaller dimensional footprint. This is something that's important so that we can make sure that there's a solution for really those low level emissions, and also safety regulations. So going for the type 2 LDAR surveys, which is the EU Methane Regulation. In America, EPO Part B compliance, as well as going for ATEX certification, Class 1 Division 2, making sure that we are still designing it in accordance with intrinsic safety in hazardous locations. So that would be sort of what would be coming out in the future, essentially ensuring that we're able to capture a spectrum of emissions in the most accurate and also the most safe way possible. And that's it from my end.
Thank you, Ashwin. Yes, over to you, Ram.
Can you see my presentation now? Hello?
No, we see the screen of all participants, and now we see.
Oh, yeah. Okay, I need to go to my PowerPoint. Now, can you see?
Yeah, we see it, yes.
Okay, so this is, I will go really fast about the OGI technology, OGAL IC Gas 2.0 or multi-camera, but I'm mainly going to talk about the OGMP reporting framework, measurement-based reporting of methane emissions, which is the level 4 emission inventory, and how we reconcile it with site level measurements, top-down measurements. That's what I'm going to talk, how to use the quantification in the camera. OGI camera is a thermal imaging camera that can visualize the gas plume, but also quantify the gas plume. So the leak detection is the part that we can see it in a certain level, we need to fix it. That's the meaning of leak detection and repair. So we need to show under the European regulation that you can see for type 1 LDAR survey to see 17 grams per hour in many conditions, and for type 2 to see the 5 grams per hour and 1 gram per hour without camera, and I'll talk about it a little bit. In order to see with the OGI camera gases, we need to have a delta T, temperature difference between the gas plume and the background. If we don't have a delta T between the gas plume and the background, we will not see the gas. So the higher the delta T, the temperature difference between the gas plume and the background, the more sensitive the camera is. And sensitivity is also a function of wind speed and distance. So I will try not to go over these equations because we have a very short time slot, but here the delta T, we are measuring actually the contrast in every pixel of the camera, and we see changes between the radiation that coming from the background to the camera when you have gas and you don't have gas, and this difference is a function of delta T, and the gas concentration that is in this term that is called concentration length. So we use to extract this information in order to quantify. The CL is what we are measuring the contrast normalized by the delta T, and we are trying to extract what is the CL, the concentration length in each pixel of the camera, and then convert it to a gas flow or leak rate of the measurement. So there are two parts of it. So the sensitivity part of detection is really depends on these three conditions: the delta T, the temperature difference, wind speed, and distance. So we will try to let you know that the Quad B, Quad C in the US, this is the US regulation that came out last year. They already defined the OGI technology as the method for LDAR survey. They only required the user, the operators, or the manufacturers to define the performance envelope in which you can do an LDAR survey, and they define 19 gram per hour, not 17 gram per hour. Originally, it was 17, and then Europe copied it from the US, and then they changed it to 19 for some reason. But 19 gram per hour, what are the set of environmental distance and wind conditions that you can measure? You can do your LDAR survey and still see these 19 gram per hours. So this is the envelope of performance, and OBGAL has defined two distances, 3 meters from the lake and 12 meters from the lake, and two temperature difference between the background and the gas plume. One is, which is very close to ambient, smaller than 2 centigrade, and one of, if you have like on the sky background, you can have a larger delta T, so you can allow yourself a wider, a more extensive performance envelope. And the performance envelope is defined by the wind speed that you can still go out and do your LDAR survey and see the 19 gram per hour. So you can see that if you are looking at a 3-meter leak in ambient condition, you can have almost 8 meters per second wind, which is pretty strong winds, and can still see the 19 gram per hour under the Appendix K, which is Appendix K is the method how to use OGI for for LDAR surveying. So this is in the US. You all know this European regulation, and that's what I want to talk about right now. The European defined two types of LDAR survey, as you mentioned before. The type 1, which is the 70 gram per hour limit. I'm sorry, I need to go back. And we treated the OGI for using this for type 1 LDAR survey. We also defined the two distances and what kind of wind speed we can still go out and measure. So we can measure 17 gram per hour at 7 meters per second when we don't have delta T. If we look at on the sky background or on a hot, warmer background, we can even go to much larger wind speed and still see the 17 gram per hour for the LDAR survey. You see it, that means you have to fix it. And our sensitivity is defined by this performance envelope. We have documents for the 5 gram per hour and for the 1 gram per hour for type 2 LDAR survey under the European LDAR program. The MRV, the monitoring, reporting, and verification program, we are following actually the OGMP, and we have participated in the GERG, the European Gas Research Group, studies, two-phase studies. One was the blind study, and the other one was a reconciliation study between source level, level 4 reporting, to site level, level 5. And site level is actually not just site level measurement, it's reconciliation of your source level with the site level, and when only after you reconcile the two measurements you can report the site level. So it's a comfort. I highlighted here measurement-based reporting framework. This is the level 4 emission inventory, which is the source level. What Ashwin said, point source leak quantification, and the site level is the level 5 measurement. You can have gaps. As you can see, these are taken from the manual, from the guidance of the OGMP. You see specific source level, level 4, and level 4 plus site level measurement or reconciliation. That's what define the level 5. You can have gaps in your level 4 measurements here, and you need to define your gaps in order to reconcile the level 4 with the site level. But you can also have the gaps in your site level measurements, and that's when the sum of all sources that you quantify are larger than your site level. So either way, you need to reconcile, and the process as they define is like a circular process. You do it every time you do it, and you do the measurement. It's a non-prescriptive guidance that the operator can choose the technologies and how to do it. You not just need to have really well described and real rigorous consideration and the uncertainty and reconciliation between two types of reporting, the level 4 and level 5. And every year you can refine it, you do improvements. So it's actually the OGMP guidance does not tell you which technology to use, and you just need to show reconciliation between the sum of all sources you measured and defined in your inventory of the level 4 with the level 5, which is the site level total emissions. So, oh, I'm sorry, I have something here. And this is a very important, the second bullet point here, the operator should focus on large emissions sources in the level 4. So from our experience in compressor station and other PRMS and other sources in the midstream and upstream, is typically the level 4, 80 to 90% of the emissions are not the small leaks that are close to the ground. It's pretty much the elevated vents that are in kilograms per hour, not in grams or 100 grams per hour. So you can cover more than 70% of your sources of your site by quantifying accurately these vents. And what we found out that probably the best tool of quantifying these remote vents and how to reach vents are the OGI, the quantification QOGI technology. And what I'm going to show you here that our OGAL quantification software has been shown to do a good job of reconciliation between source level and site level emissions. So we participated in this GERG emissions. I will go really fast. So just the basic, what we do, we measure the concentration in pixels. We integrate it over a plane downwind from the source, and we use some algorithm to evaluate the wind speed, and we get a quantification which is in leak rate. It could be gram per hour, kilogram per hour. It could be cubic feet per meter square, cubic meter, all kind of units, but it's a leak rate, it's a flow rate of the gas that we can quantify with the OGI technology. It's not, we are not looking at quantifying at ppm, at concentration. So this is an example of our software. I'll show this movie very shortly. This is an example. We measure these vents. You have two vents are leaking here or emitting methane. This is natural gas. You can see this is in a power plant. The distance is about 60 meters, and you can see the gas going through this plane. We can see when it go below the plane, it's a leak rate. We can evaluate the ppm values, but we can also see the gram per hour. So you can see the gram per hour, it's actually kilogram per hour. And we found out that in most sites, these vents are the main methane emitters, not the leaks from small pinholes from the processing area. So I will move forward. So we did some calibration. We compared a tunable diode laser with our 1 pixel to show that we can really measure very accurately the CL. And we participated in 2 phases in the European Gas Research Group. In the first phase, it was blind testing of 17 control released unknown release emission rates, and there were 10 technologies that participated. The top 5 in this graph are site level, as you can see, and the bottom 5 over here are the source level. And we, out of the source level, there were 3 OGI technologies, and out of the 3 OGIs, this is us. The other ones I cannot mention, but we provided the best source level quantification out of the all source level technologies, and much better than the 2 other OGI. And this is published in this paper. It's a peer-reviewed paper. Everybody can approach this paper. I can send you the link, and you can look at it. The second phase was this source level and site level methane emission reconciliation study. We surveyed for 2 days in 2 modes of operation. One, that the compressor works. Mode 1, it didn't work. Mode 2, it did work, the compressor. And we did a site survey with a lot of technologies, you can see. But we were selected. We have iFlow sampler and the QOGI. We were representing the QOGI upon our success in the first phase. And all the other technologies were site level, continuous monitoring technologies. And my point here is that the iFlow sampler can do a good job on close to the ground, small leaks, but when you go to the vents, I cannot share what are the other technologies. This data is belong to the 15 members of the GERG of this study, and we cannot publish the results. All I can publish is that our results, we reported 12 emissions, and we have 100 reconciliation on the area level. On the site level, in mode 2 and mode 1, we reconciled. So we reported our frequency, our utility of reporting source level and site level was very high, and our reconciliation was 100% reconciliation on the area level and site level reconciliation. The sum of our emissions always reconciled with the site emissions that it was known to the operator. So the bottom, the final remark that I want to make, the QGI is very good for remote vents quantification. Our OGI is the best. This is a proven study. And as far as the OGMP and that reporting, the MRV monitoring reporting, these vents are the majority of the emissions at any sites, because they are in kilogram per hours and not in grams per hours. if you do a couple of these events right, you pretty much can reconcile it for the site level emissions. The other emissions are negligible. So thank you very much, and I hope I was in time. Hello?
Brilliant. Thank you very much, Ram. All right. Yeah, I'd like to encourage everybody who is attending to ask any questions if you'd like in the chat. There have been a couple of exchanges there already, so you can still write any questions or remarks there if you like. I'd like to slowly wrap up the hour that we had planned with a short presentation of what we are doing as SensorX Solutions. What kind of innovations are we bringing to the market, which is helping customers become compliant to the EU Methane Regulation. So we have developed a methane detection platform based on tunable diode laser spectroscopy, TDLAS. It's a very modular platform. We call it the Flux Multi. So you have a core sensing unit that you see in the center there, and this can be used for different modes for site and source level measurements. So it's a methane sniffer. It's available in two variations, so methane only measurement and a methane plus ethane measurement as a marker for natural gas. You can deploy it on drones. We provide a complete onboard computer for all standard drones like DJIs and so on, where you can plan the flights, you get all of the data, etc. So for site level monitoring, that's an excellent solution. You can sniff the sampling gas using a hanging tube or a sideways arm. You can install the unit on a car for driving surveys. You can carry it on your backpack or as a belt accessory with a belt accessory for sniffing walking surveys. And you can use the same unit to install in a stationary unit where we also measure the wind conditions, the speed and the direction and so on. A completely autonomous unit for site level continuous monitoring. So yeah, with the same unit, you are able to cover many different use cases. So I'll just very quickly go through those different use cases. That's the walking survey that can be done with the Flux unit. We call it the Flux backspecs mode. Then we have the drone survey mode. We call this the Flux Aero. We have partnered with a company called SPH, which does the onboard computer and the software and so on, so that you can do autonomous flying of drones. You see those two modes that I mentioned before, the sideways arm and the hanging tube from the Flux Aero. The Flux Motion for vehicle, for driving surveys. Also, this can be placed inside the car, in the trunk of the car, or in front of the car, for example, and then with sniffers mounted in front of the car, you can do the methane measurement while driving. Then you have the stationary continuous monitoring, a completely autonomous unit with an inbuilt battery and a solar panel, so that you can install it along the perimeter of any site. So we have quite a bit of success with the compressor stations, for example. There, the value also comes from the very nice software that kind of does that continuous monitoring. You can set alarms. You get a quantified value, so we have a very strong simulation of the leak plumes that are created there. So based on a very sophisticated dispersion model, we are able to tell you where the leak is coming from and how big the leak is. So the quantified value as well. So that's the Flux Station. So that's the Flux Multi as a platform. And as I mentioned before, we are also foraying into inspection services. There we are partnering with HETEC, who's also present on the call here today. So we are also already providing this to a number of large European operators here in Europe. I'd like to share a few thoughts from the experiences that we've gathered so far. So what we have seen is, operators, of course, they are investing a lot in understanding what the regulation means for them, for implementing measures that will make them compliant. However, operators are very happy if they get end-to-end inspection services. So as a solution provider, so there's a good room for solution providers in Europe because of the regulation now. Of course, there are a lot of great technologies, a lot of great products out there which can be used for specific purposes. So we saw a couple today. Each technology, each product has its strengths and weaknesses in that sense, has a good fit for certain use cases. But operators are very happy if they get a complete solution in that sense, because the whole landscape is a bit complicated. The importance of cutting edge technology is not to be undervalued. So for example, we really pick out the best technologies out there for when we provide the service, whether this is coming from our own portfolio like the Flux Multi or other manufacturers. So we use the AMLD vehicle-based system, the Discover system from ETH, from the US, for example, for our driving surveys. We use our backpack sniffers for the walking surveys. We use the HETEC high flow sampler for source level quantification, the OPCAL OGI for visualization and quantification, and many, many more other excellent technologies as well. What is very important is, of course, a central software platform, because you create a lot of data as you provide these services, and you need to keep this efficient by using intelligent, smart software solutions. So that's where we see a lot of added value for our clients as well. Right, and the last point is certainly kind of an internal quality and certification process for our inspection team, so that we are able to guarantee real compliance and very high quality coverage of the different networks or distribution networks, assets, and so on. So that's also very well received in the market by our clients. Right, so that's a short presentation of the EU Methane Regulation today, and a few presentations of the technologies of the high flow sampler and the OGI camera and the Flux Multi. And I'd like to close formally the talking part of the webinar. There's still 1 minute left for the planned time. If there's any more questions, a couple of questions that came in through the chat were already answered there. So there's nothing else coming up. So I'd like to close up the webinar. I'd like to once again thanks Ashwin and Ram for joining today and sharing their insights and experiences. And I'd like to thank everybody who attended the webinar as well. We are there as a team available for you, SensorX, HETEC, and OPCAL. Reach out to us if you need support to understand the technologies or the services that are available, or understanding the regulation. We are there to support you. So thank you very much. Any last words, Ashwin and Ram, for today and for the webinar?
Thank you.
No, thank you for your questions.
All right. Thank you very much. Have a nice day, everybody. Bye-bye.
Bye. Bye.